Welcome everyone. Oh yeah, 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 yeah. Don't worry about it. This is a 10th grade physics exam. We're going to sorry. We're going to start solving the physics by Mr. Exam uh, A. Well, in this case, remember we have two physics by Mr. Exam A and B. Today we're going to discuss the by Mr. Exam A. Tomorrow the B, and it got wills. The next days we're going to discuss the accumulate. Okay, and remember, if you have doubts, questions, don't hesitate to let me know. All right. So it's going to start in a few minutes, in a few seconds. Oh, okay, let's going to start solving with the first problem. The first physics problem, not a big deal, not complicated thing, but that was a little detail that we're going to discuss at the moment we're going to solve this exam. Okay. All right. So in the first problem, or the problem number one, in the exam A says, when water freezes, when water freezes, when water freezes, it expand, it expand, it expand about 90%, about 90%. And the question is, what will be what will be the what will be the pressure increase what will be the pressure increase inside your automobile your automobile's engine lock engine lock um if the water in it froze, if the water in it froze. And the problem gave us the bulk modulus that will be 2 times 10 to the 9 power pascals. Okay, what will be the situation in this bulk modulus? Okay, guys. First of all, the first thing that we have to do is identify the data from the problem. Remember, in this situation, this expansion about the 9% that will be represent the volumetric deformation. That will be 0.09 or the 9%. The crown that we're talking about. The bulk modulus, as soon as you can see, will be 2 times 10 to the 9 power pascals. Okay. And finally, the problem asking for what will be the value for the pressure. Okay, remember, the water is freezes and we're supposed to expand that volume, okay? With the expansion of the volume to increase the value from the pressure, we're going to move inside, we have to move some kind of distance deeper for the instead to have the pressure in the highest point, in the lowest point for any surface is when the particular has the highest value of the pressure. For that reason, if you remember, the formula for the bulk modulus will be given by negative pressure divided by the volumetric deformation. Why negative? Because negative, because in the highest value or the increasing value of the pressure in the bulk modulus appears or happens in the slower path in any situation. That's why we include the negative sign of the formula. And because we're looking for the value from the pressure, negative volumetric deformation times ball modulus will have the value of the pressure. So simple merely words, we have to multiply negative 0.009 multiplying by 2 times 10 and the 9 power pascals. And this is going to be the value from the pressure. And the value from the pressure, my dear students, will be negative 1.8 times 10 at the 8 power pascals. And this is going to be the solution set. Why negative? Because in the deepest distance or profundity in any situation, this is going to have the maximum value for the pressure in the bulk models. That's why the negative sign. Remember, if you have doubts or questions, don't hesitate to let me know. All right. Some of you, well, actually, almost the students have the same, almost the same answer, 1.8 times 10 to the 8 power pascals, but they're excluding the negative sign. Is that not going to happen? Because the negative sign, that means the increase of the pressure happens in the slower part in any body or in any situation. That's why you have to include that negative sign in your answer. Okay. So in the problem number 2, sorry, says a large storage tank, large storage tank, open at top. This is so important. Open at top. Open at top and filled with water. And filled with water. And filled with water develops a small hole in its side a point 16 meters below 16 meters below water level. Water level. Okay, period. If the rate of flow, from the leak is 2 times 10 at the negative third power, 2.5 times 10 at the negative third power cubic meters per minute. Okay. Determine what we have to determine. Letter A, we had to determine the speed of water, leaves the hole, and the letter B, diameter of the hole. Okay, this is going to be the second question. What we have to do? Well, in optional step, if you really want to apply the situation, we can create a free body diagram of the situation. This is going to be just approximation of the large storage tank that's supposed to be a hold located over here, right? Obviously, inside this tank, we're talking about that include water. All right. So, and this is going to we're going to have a fluid road or water. We don't know what will be the velocity. According to this situation, this liquid, the water liquid, that's moving a fluid rate or fluid road. In this case, will be 4.17 times 10 at the negative feet power, and the negative feet power in this case will be cubic meters per second. Cubic meters per second. Remember, only because this is meters per cubic meters per minute, 1 minute has 60 seconds. We have to divide this answer by 60. And the problem mentioned what could be the velocity, this value of the velocity when the water is goes out. And we have a height level from the ground. In this case, that was supposed to be 16 meters in this 340 diagram. And at the same time, this large storage tank is open to the top. And we have a hole. What does that mean? This is a Bernoulli's case in open pipe tube. Remember, it's an open pipe. That means that input pressure, I mean the P1, that's supposed to be the pressure number 2. So how we can solve this problem? Remember, applying the open pipe case, okay, the Bernoulli equation established 1/2 density, velocity 1, second power, plus density gravity, height number 1, that will be equal 1/2 density, velocity 2, second power, plus density, gravity, and height number 2. We are avoiding the pressure number 1 and the pressure number 2 because we're talking about an open pipe case. So we have to analyze the situation. What will be the initial velocity of the water be inside a hole? Well, before to open the hole in this situation, the fluid is moving at rest. Okay, because it's at rest, there is no velocity at the beginning. For that reason, this part of the formula can be canceled. However, we have a height, obviously, at the beginning, we have 16 meters high from the ground. How about in the second one? I mean, at the end, obviously, the final velocity, we have to calculate what will be that velocity. Okay, and after we know what will be the velocity, we have to analyze what will be the height of the fluid once they're going to exit the hole. And because it touches to the ground, there's not going to be some kind of body from height. For that reason, the second part of this formula can be canceled because the body from height will be 0. And what we have to do, you have a new formula. Density, gravity, height 1 equals 1/2 density, velocity 2 at the second power. Because the density is talking about the same liquid, water, it can perfectly cancel. And if we're solving by the velocity, this is number 2 is divide, passes to multiply, and we got the square root of twice gravity and height. That will be the value of the velocity that we are looking for. And this analyze, my dear student, has a name, is the Torricelli theorem. Torricelli theorem established the velocity of the liquid that will be the square root of the product of twice the gravity and height. And now what we have to do, simple. The only thing that we have to do is replace, trying to looking for what will be the velocity. You know, 2 times the gravity, 9.8 meters per second square, multiplied by the value from height, that will be 16 meters. And we got the value from the velocity. And the value of the velocity will be 17 4.71 meters per second. This is going to be the first solution. The second one, we had to calculate the diameter. Well, to calculate the diameter, remember, we have to apply the equation, the fluid road. Remember, the fluid road, it could be obtained divided by the volume, divided by the unit of time, or multiplying the value from area times the velocity. So if you really want to know the area, we have to divide fluid flow by the velocity, and that we have the value from the area. That's why we transform the fluid road, I mean 4.17 times 10 at the negative fifth power cubic meters per second divided by 17.71 meters per second, and we're going to have the value from area. So as soon as you can see, we can cancel seconds with seconds, cubic meters with meters, and the answer will be given by square meters. And the value from the area will be given by 2.35 times 10 at the negative 6 power square meters. This is going to be the value from area. But remember, in the letter B, they're asking for, okay, what will be the diameter of the hole? Diameter. No, they're not asking for what will be the area. And you know, area, because the hole has a circular shape, will be pi over 4 diameter at the second power. And because we're looking for the diameter, this number 4 is divided, passes to multiply 4 times area divided by pi square root, and that will be the value from the diameter. Simplementary words, diameter equals square root of 4 times 2.35 times 10 negative 6 power square meters divided by pi. So diameter will be given by 1.73 times 10 at the negative third power meters. And this is going to be the solution set of the problem number 2. Questions? Before to continue, guys, do you have some questions or everything is clear to this part? Hmm?
Mr. I
Hmm.
just have one question.
Hmm.
Why do you, in height 2, why do you cancel the height? Like, why is it 0?
The height number 2.
Uh-huh.
Because remember, in the position, the letter where it's located, the letter B will be position 1. And when it reaches the ground, that will be the final position. So what will be the height of the water at the moment the water touches the ground?
Okay, so
That's
0.
why that will be 0. That's
Mhm.
why I cancel the second part of the problem, because the second height will be 0 units. That's why. Okay. Now let's going to solve the problem number 3. Archimedes principle of buoyancy force, if you want to say that situation. I don't know, guys. Some of you create a disaster, a mess of the moment they're going to solve this kind of problems. You know, in this principle, we have to use free body diagram. There is no way you can obtain the equation without the free body diagram. It's a mandatory requirement to solve that situation. If you don't create the free body diagram, there's no way we can solve the problem. Okay, it's so simple in the problem number 3. It says a plastic sphere. A plastic sphere floats in water. Floats in water. Okay, floats in water with 50% of its volume, okay, submerged, okay, submerged. Okay, the same sphere floats in glycerin with 30% of its volume submerged. Submerged. It's what the problem asking for. Okay, in this case it says determine the densities of glycerin the glycerin and sphere. Okay, and that's it. That's all that we have to do in the problem number 3. We have to determine the difference between these two bodies. What we have to do in the problem. Remember, every time they went to solve any problems using Archimedes process, we had to create the free body diagram. Okay, how we can proceed? Simple. We're going to analyze the situation when the body is submerged in water. In water. That's why I labeled the word water. And that's going to create the free body diagram. If you see in the free body diagram, not big deal, not so complicated thing. We have y, negative y, x, and negative x. What forces are acting in this case? Well, simple. We're going to have the buoyancy force provided by the water, okay, and the weight of the sphere. WS, that means weight of the sphere. What we have to do is going to apply the addition force, okay? The addition y forces over positive equals 0. We have the buoyancy force minus the weight of the sphere, that will be equal 0. Buoyancy force equals the weight of the sphere. What will be the buoyancy force? Density of water, the submerged volume times gravity equals the mass of the sphere times gravity. Because the gravity will be the same, it can be perfectly canceled. And remember what the problem says. The submerged volume will be the 50% of the real volume of the sphere. For that reason, density of water multiplied by 0.5 times the volume equals mass of the sphere. You know, the mass of the sphere can be obtained multiplying density of the sphere times the volume. Okay, and because this volume is multiplying when it passes to divide, the value from the B can be canceled, and we can conclude the half value of the density of the water will be the density of the sphere. So, you know, is 0.5 multiplied by 1,000 kilograms per cubic meters will be density of the sphere. So the first one will be 500 kilograms cubic meters density of the sphere. And that's it. Do we have the response? The first question. Now let's going to respond the second one. What happened if this submerged in glycerin? Glycerin. What will be, how will be the second free body diagram will be the same. The only thing they're going to change, obviously in the buoyancy force, instead to use water, we're going to use the glycerin because the glycerin acting like a liquid density. But if you see, no big deal, not complicated problem, because if you're checking the solutionary, guys, the solutionary, obviously they're going to use a hue and mass complicated issues of the process. But this is in order that we have to require to solve in this kind of situations. If you see order, now big expansion in 1, 2, 3, 4, 5, 6 rows, and that's it. Okay, so let's continue. Addition, y forces over positive equals 0. We have the buoyancy force subtracting the weight of the sphere equals 0. Buoyancy force equals the weight of the sphere. Density of the glycerin uh, submerged ball times the gravity equals the mass of the sphere times the gravity. And because the gravity is the same, it can be perfectly canceled. And remember, the density of the glycerin can be multiplied by, in the second case, 40% of the volume submerged. I mean, 0.4 times the volume. And you know, the mass of the sphere, once again, we have the density of the sphere multiplied by their volume. And because this letter B is multiplying when passes to the by, it can be perfectly canceled. For that reason, the density of the glycerin will be given by density of the sphere divided by 0.4. And simple, not any worse. For that reason, density of the glycerin will be 500 kilograms per cubic meters divided by 0.4. So density of the glycerin will be given by 1,250 kilograms per cubic meters. And this is going to be the solution set of the problem number 3. Questions on this part, or everything is clear, guys?
Everything's
Okay,
clear, Miss.
then. Now the problem number 4. Yeah, over here that will be right. Okay, this is a clear example in the problem number 4, guys. Why? You don't need always trust in the with applying faith in the solutionary, and especially when in this kind of questions. For example, the problem mentioned we have a volumetric glass flag, a volumetric glass flask made of Pyrex, made of Pyrex, made of Pyrex, is calibrate, it's calibrate at 20 Celsius degrees, at 20 Celsius degrees. Okay, it is filled, it's filled to 100 milliliters, 100 milliliters, marked with 31, mark, obviously, with 35 Celsius degrees acetone. Okay, with it immediately, with it immediately, immediately comes to thermal equilibrium. To thermal equilibrium. Okay, period. Letter A says, what is the volume of acetona? What is volume of acetona when it's cooled? When it's cool, it cools, sorry, it cools to 20 Celsius degrees. All right, not big deal, the letter A. But this is going to be the remarkable process in the letter B. In the letter B says, how significant is the change? How significant? How significant is the change of volume? If the change of volume of flask. Okay, what we have to do? Okay, first of all, we are looking for the new volume for the acetone. Okay, you know the formula, change of volume, delta B is given by a beta, initial volume, delta T. And this change of volume can be obtained subtracting the final volume minus initial volume equals beta, initial volume, delta T. And solving by the final volume, we have initial volume plus beta, initial volume, delta T. Okay, not a big deal. Taking the common factor, and the final volume will be initial volume, parentheses, 1 plus beta, delta T. And the only thing that we have to do in this problem is replace those values. I mean, the final volume will be 100 milliliters multiplied by 1 plus, remember the value from beta is a given value by 1.5 times 10 at the negative 4 power over Celsius degrees, and the change of temperature because the acetone will cooling down. That means the final temperature that's supposed to be 20 Celsius and the initial temperature will be 35. So that reason 20 minus 35 will be negative 15 Celsius degrees. So in the part 8, the answer will be 99.78 milliliters. Okay, this is going to be the solution set of the Pyrex. This is not supposed to be the final volume. And remember that change of volume in that situation, if you really want to know what was the change of volume of the acetona, that's supposed to be negative 0.22 milliliters. Why? Because there's cooling down. It's decreasing 0.22 milliliters. Now the moment of through. The problem says, okay, how significant is the change of volume flux? Well, first of all, we have to find out what will be the change of volume from flux. Remember, delta B equals beta initial volume, delta T. This is the first thing that we have to do. Okay, so beta, remember, is a class of fighters. We have to try to find out what will be that value, the value from alpha. That's supposed to be 3.2 times 10 at the negative 6 power. But because we're talking about that was a solid, the value from to transform alpha to beta is multiplied by three dimensions. For that reason, the value that we're talking about will be 9.6 times 10 at the negative 6 power Celsius degrees, 100 milliliters, and delta T will be the negative 16 Celsius degrees. I'm going to move the camera a little bit to the right. Okay. So what will be the next step? Simple. Only multiply those values. And this answer will be negative 0.0, 144 milliliters. And you're going to ask, okay, mister, but why we have to try to find out the change of volume? Because we really need to know what will be the change, how many times the volume from the flask will increase according to the thermal dilation with the volumetric change of the acetona. Well, so the number of times that we have to do this situation is divide. I'm going to do it over here. The number of times that will be given by the change of volume. In this case, once again, the liquid, the change of volume, the liquid, that will be 0.22 divided by 0.0144. Why positive? Because negative times negative will be positive. For that reason, the answer will be 15.27 times. This is going to be the solution's answer, the solution set of the problem number 4. But I don't know why or where you got 6.4 times 10 to the negative 2 power. Actually, I have no idea why you're using that connotation. I don't know. I don't know if anybody can be explain that situation, because I don't know why you obtain the answer. Okay. So, and this is going to be the problem. And the problem mentioned, if I remember, 1 over 6.4 times 10 to the negative 2, or something like that. There was the most of the answers that I got in the problem number 4. I don't know if somebody else can be can explain how you got that answer. Because we have a good, excellent, good exams, okay? But in the problem number 4, in that part, I have no idea where you got 1 over 6.4 times 10 to the negative 2 power. I don't know why. Any explanation? Well, I have no idea why. Well, we have only 1 minute left to conclude the class, okay? If God wills, tomorrow, we're going to solve the problem number 5 with exam by Mr. Exam A, and we're going to continue solving the by Mr. Exam B. And tomorrow, I'm going to start with discussing the obviously finish the second exam. We're going to finish the exam in math and discuss the accumulate. If we are advanced in a quickly speed in that situation, we can discuss the physics accumulate in the same hour or vice versa. Okay, guys, we are out of time. Thank you so much for the attendance. Have a great and wonderful day, and see you tomorrow if God wills.
Bye.
Bye bye. And by the way, can you see perfectly well the problems? It is better. The quality of the imaging is better than the last classes, or not?
Yes.
It's better, right? Okay. Thank you so much, guys. See you tomorrow then. Take care of yourself.
Thank you.
Bye bye.
Thank you. Thanks.
My pleasure. See ya.